So AI models are getting insanely powerful, right? And that means the whole game is changing. The real competitive edge, it's no longer about if you use AI, but how you use it. It's about actually truly harnessing its power. So let's dive right in.
Look at this. We've all seen a mess like this before, a total chaos of wires. It's tangled, it's unreliable, and trying to manage it is a nightmare. Well, this right here, this is basically how most companies are deploying AI agents today. It's this super complex system with absolutely no real structure. So the big question is, how do you bring any kind of order to that chaos?
You know, in the car industry, they solved this problem a long time ago with something called a wiring harness. It's actually this really brilliant piece of engineering that takes all those separate, messy wires and bundles them into a single, secure, totally reliable system. It manages all that complexity, it makes sure everything is safe, and it just makes it all work together seamlessly. This physical harness, it's the perfect metaphor for what we desperately need in the world of AI.
Because let's be honest, building with AI right now can feel just like dealing with that tangle of loose wires. You know, we throw a prompt at a model, we hook it up to a bunch of different tools, and then we pretty much just cross our fingers and hope for the best. That whole approach is inefficient, it's unpredictable, and it is definitely not a sustainable way to build serious production-grade systems.
I love this quote. It just nails a huge shift in mindset that we need to make. It perfectly captures the new role of a developer in the age of AI. Your job isn't really to do the work yourself anymore. It's to create a well-designed environment, an office, where your AI agent can do its best work safely and effectively.
So how did we even get to this point? Well, you can see this evolution in how we think. It started with prompt engineering, basically figuring out what's the best question to ask. Then we leveled up to context engineering, thinking about what information the model should see. And now we're at this third and I think most crucial layer, harness engineering. This is where we ask, how should the entire environment be designed? Each step builds on the last, but it's the harness that really governs the whole shebang.
And that right there brings us to the core idea of this whole explainer, harness engineering. It's the discipline that lets us move beyond just guesswork and start engineering our AI systems with real intention. It's the framework that can transform a powerful but chaotic AI model into a reliable, production-ready asset.
So what does a harness actually do? Well, it really boils down to 4 key actions. First, you constrain the agent. You set firm, non-negotiable boundaries. Second, you inform it with exactly the right context for the task at hand. Third, you verify its output using automated checks. And finally, and this is critical, you correct it when it messes up, creating this feedback loop so it can improve. Constrain, inform, verify, correct. Get those 4 things right, and you've got the heart of a great harness. Okay, so that's the what. Now for the how. A really solid digital harness is built on 5 core pillars. Let's break down exactly what they are. All right, pillar number 1, the context engineering layer. To get this, think about the computer on the Starship Enterprise. It doesn't just dump the entire ship's database on Captain Kirk, right? No, it gives him exactly the right piece of information for the specific crisis he's in. A good context layer is like that. It's a dynamic supply chain, giving the agent precisely what it needs to see and absolutely nothing more. Second, we've got architectural constraints. And listen, these are not just friendly suggestions you stick in a prompt. No way. Think of them more like Asimov's laws of robotics. They are hard-coded rules that an agent physically cannot break. So, for example, a trading bot can't place a trade over its set limit because the harness infrastructure itself just won't allow it. It makes bad behavior impossible, not just discouraged.
Pillar number 3 is something called entropy management. See, when you have AI agents creating hundreds or thousands of outputs a day, they can start to copy their own bad patterns or drift away from your standards. And this slow, creeping decay in quality, that's what we call AI entropy. The fix is to have other background agents that are constantly scanning for these little inconsistencies, and they either fix them automatically or they flag them for a human to review. They're basically the quality control inspectors for your AI's work.
The 4th pillar is all about verification and feedback loops. This is the self-correcting heartbeat of the entire harness. Here's how it works. An agent produces some output. An automated check immediately runs to validate it. And if it fails, the error itself gets fed right back to the agent as new context. The agent then takes that feedback, revises its work, and tries again. And it just repeats that cycle over and over until it gets it right.
You know, OpenAI has the perfect name for this, and it's hilarious. They call it the Ralph Wiggum loop.
If you're a fan of The Simpsons, you know exactly what they mean. The agent doesn't get frustrated, it doesn't take the feedback personally, it just blissfully keeps trying, taking in each correction until the job is finally done. And that persistent, non-personal approach, that's a genuine superpower of these AI agents.
And finally, our fifth pillar, security. And let me be super clear about this. This cannot be an afterthought. The real risk in AI isn't the model going rogue. It's the harness that gives it the power to take actions in the real world. So security has to be baked in from day one, using principles like isolating permissions and always requiring a human to approve any high-stakes actions.
Okay, so that's the theory. It sounds great, right? But the big question is, does it actually work out in the real world? Well, the evidence from teams that are already doing this is, it's just dramatic. We're not talking about a small improvement here. This is a revolutionary leap.
Just take a look at OpenAI's Codex team. In only 5 months, they shipped 1 million lines of production code. 1 million. I mean, that's an absolutely staggering number. But the truly mind-blowing part is how they did it. That's right, 0. Not one of those million lines was written by a human. The secret weapon here wasn't some magical new model. It was the harness. They built a system with super rigid constraints, totally automated verification, and that entropy management we talked about. And that's what guided the AI agents to success.
And this isn't just about cranking out code either. Other organizations using these same principles are reporting that they can onboard new engineers 85% faster. That's because with a well-designed harness, even someone who just joined the team can create production-ready pipelines that meet all the company standards from their very first day.
You see the pattern here, right? It's all over the place. OpenAI got a 10x boost in velocity with those tight constraints. Vercel did something that sounds crazy. They actually took away 80% of their agent's tools, and its accuracy shot up from 80% to a perfect 100%. And LangChain, they didn't even touch the model. They just changed the harness, and they jumped from the top 30 to the top 5 on a major coding benchmark. The lesson is crystal clear. Smarter constraints lead to way better outcomes.
So, what's the big takeaway from all of this? It's pretty simple. For anyone out there building with AI today, your new competitive edge is not going to be the model you choose. It's the harness you build around it.
I want you to think about it like this. The AI model, that's the engine. It's powerful, yeah, but it's just one part. The harness, that's the entire car. It's the chassis, the steering, the brakes, the safety systems. And as these AI models become more and more of a commodity that anyone can get, it's the unique, robust, and intelligent harness you design that is going to set you apart. That's the durable differentiator. That is the real competitive advantage.
So, as these AI models just become the standard engine that everyone has access to, the most important question is no longer, which engine should I use? The really crucial question is this: what incredible things could you build if your harness was designed just right?